Hello, my name is Gerth.
And I'm Roland and this is our final application for EC 420 at the University of Illinois.
Our final Android app project was to build an application that would demonstrate different types of image filters that are used today and show their effectiveness against different types of distortion or noise that exist within an input signal.
The application was built in the Eclipse development environment with the Android SDK and NVIDIA Tegra Pack for native C++ code development. C++ code helped us to create efficient DSP code, and we also use the OpenCV libraries for image type conversion and data structure definitions.
We implemented two different types of median filters as well as a bilateral filter. Median filters are based on a nonlinear algorithm to select each output pixel based on the median value of a selection of pixels near the corresponding input pixel. It allows us to reject either shot or salt or pepper noise by throwing out odd pixel values. Also, using the median filter rather than the average allows us to preserve any edges that exist within the image without blurring them out.
The bilateral filter is a linear algorithm which utilizes Gaussian weighted sums of all the pixels in the image to generate each output pixel. Only input pixels which are close in proximity and similar in color will have a large influence on the output pixel. This gives it the ability to smooth out Gaussian noise on the input signal without destroying edges or other decels in the image.
As you can see, our application displays the current type of filter that is being applied to the camera video stream, what sort of noise has been added, if any, and what the SNR is if we have extra noise.
So I'm now going to turn on shot noise. And we can see that the SNR, well, you probably can't see it, but the SNR is a value of 6. It is quite low since the noise introduces much distortion. However, when we turn the median filter on, the SNR increases dramatically to 27.
The image almost gets completely fixed by the median filter. The bilateral filter does not work as well against this extreme noise because the distorted pixels are far enough away from their original values that the bilateral filter thinks that they're edges and tries to preserve them as such. As a matter of fact, it actually makes the SNR a little bit worse, I believe.
So switching over to the bilateral filter, the SNR changes to a low 10.
Yep.
As you can see, the SNR...
However, if we change over to Gaussian noise, then the SNR will go up because this is the type of noise that the bilateral filter is much better against.
So switching over to Gaussian, we see definitely an increase up to 35 or 39. This indicates a qualitatively better result from the filter. There's visually much noise still present in the image, and this is due to the fact that a more powerful or more aggressive bilateral filter uses a lot more processing power and would slow down the frame rate too much. However, even with this very weak filter, we can still see the SNR is increased from what it would have been if there was no filter. So with no filter, the SNR goes down.
Yep, it goes down about 20-ish. We had to perform some optimizations to get the frame rate as high as it was in this demo, even though it wasn't super high. We use a method of calculating the median that involved using a couple histograms. We also did some different ways of indexing into arrays that were faster, as well as eliminating as much of the floating point math as possible to speed up the processor.
It's our hope that our app will allow users to explore the different types of filters and find out what sort of images and noise levels they perform better against.
Thanks for watching.